Welcome to the part 1 of a trilogy that will completely change the way you think about deploying applications with Docker. Over the next few weeks, we're going to show you 3 distinct deployment strategies. And today, we are kicking things off with the rawest one, a 100% manual deploy, no containers, no shortcuts, just pure fundamentals. This series is built for those who want to go beyond tutorials and truly understand the deployment process before jumping into Docker and Docker Compose automations and things like that. And Herbert Pereira will be leading this first step. Stick with us until the end because this episode will give you the foundation you need for the next 2 parts. Let's dive in.
In this video, you'll learn how to fully deploy a microservices-based Python Flask app, exploring 3 practical deployment approaches from end to end. We're going to divide this Docker edition into 3 parts. In part 1, we're going to do the traditional deployment without using a container with a 100% manual process. In part 2, we will deploy using containers with Docker, which means we will need to package the application, build it, and run it with containers for better isolation and portability. And in part 3, we will deploy with Docker Compose multi-container applications, a 100% automated process using a simple and readable YAML file. And this is the structure of the project. These are the components of our architecture. We are going to have component 1, which is going to be a microservice that manages active users. We will have component 2, which will be a microservice that manages products, and we will have the front end, which will communicate with these other components. This is just a simple example to help us develop our hands-on practice, but in a real-world environment, you will typically have multiple integrated components and microservices working together. In this part 1, we will only be using and managing the application files within our microservices architecture. So each component will have its own application file, and it will also contain its own requirement file, which includes all the necessary dependencies needed for the application to work properly. Likewise, each component will also have its own Docker file, which we'll get to in part 2, when we'll need to run it with a container. From the part 1, we will only be manipulating the application and the requirement files. In part 3, we will need to populate the Docker Compose YAML file with the required services and configurations to run the application properly using Docker Compose solution. That said, I am using a virtual machine EC2 instance, which I created under the name Docker Host. And this machine already has Docker installed and the Python that is needed to run this hands-on. So let's move on to part 1, traditional deployment without the use of a container, the 100% manual process. So now I'm logged in, I'm going to open the project folder. Remember that I'm using a specific version, actually an extension of VS Code, to remotely connect to this virtual machine hosted on AWS and make my life easier when editing configuration or source code files. Just wait for it to open. Now let's request a new VS Code terminal in our development environment and start the process of creating our project's initial file structure for the application. To begin with, I'll adjust the prompt by running the export command here to make it easier to view on the screen. This gives us more space and clarity to work with. After that, the next command is exactly what we need to create the project's file structure. It will automatically generate all the essential folders and files required for our initial setup. So that structure I showed you earlier has already been created. As you can see, it includes component 1, along with the necessary boilerplate for development. Now, all these files are empty for now and we'll populate all of them later. Note that all the components have basically the same structure and files. In addition, we also have Docker Compose file, which will be used on the video of the part 3. Let us populate the application code. We will begin with the first component of our project. I will minimize the terminal window so we can focus on the code. Component 1, let us go ahead and populate this file. It is a simple file containing basic logic. And as I've already said, our focus won't be on the application code, but on its essential part. For example, this microservice component 1 will be responsible for rendering a specific page and will respond to incoming requests on port 5001. This information is important because when you run the container, you need to know exactly which port you'll be exposing to the outside world in order to access your application correctly. You can assume the developers have already built the application and provided all the necessary files and configurations required for you to deploy this process. As I showed you, in addition to the application file, every component has its dependencies and packages that need to be installed. And this is done through the requirement file. So for this application to work, we'll need these two packages. Now go to component 2, open the file, and copy the provided code into it. Note that application 2 will run on port 5002, so I have component 1 running on port 5001 and component 2 running on port 5002. In the same way, we need to populate the requirements file with all the observations and notes made by the development team, where we pass on the information about the specific dependencies we need to install for the application to work correctly. That done, now let's configure the front end of our application. Let's copy the front-end code and note that the front-end runs and listens on port 5000. It also has some environment variables. Specifically, it will communicate with these other two components through environment variables that will be dynamically populated at runtime with relevant connection information. You'll have these two environment variables where it will give a curl command. It will be executing this information, saving it in this variable. So this way, this component will be able to communicate with these other two components, right? That's how the front end will communicate with the two microservices. Similarly, we'll also need to include all the necessary dependencies and libraries required for the front end to function properly in the requirements file. This represents the manual deployment process, which is precisely the step-by-step goal we're focusing on in this video, part 1. Once we have these files created, which are necessary for deployment, now we're going to understand how to deploy manually, the traditional deployment without Docker. You'll notice it's a sequence of commands that you repeatedly use throughout the process. This highlights one of the key advantages of understanding the DevOps ecosystem, recognizing how automation can streamline tasks and significantly boost efficiency. Let us run the LLs and list the project directory. Next, we are going to open 3 separate terminals. First, we will focus on configuring the part related to component 1. So if we list it, we can see there is a folder for each component in the project. Let us access the folder for component 1. And inside this component 1 folder, it obviously includes the files we have just populated during the initial setup. And so that we can run our application properly and isolate its dependencies, we need to create a virtual environment. For that, we use this Python command, which leverages the built-in venv module to create a virtual environment, also named venv. If we refresh the file explorer, we'll see that a new folder has already been created automatically. And inside this folder, it has a few subfolders, including one with a binary, which has a script that you can use to activate this environment, which is precisely our next command. We're going to activate this environment so that we can install the necessary application files. Here at the terminal prompt, you can see that I'm already inside this virtualized environment. Using the pip command and passing the requirements file, we'll install all the libraries and dependencies needed for this application to run properly. It's important that at this point you start to think critically about the number of commands you need to type and execute for your application to work properly. Now we are going to upload the application to the environment. Component 1 is already running. I will open another terminal so we can repeat the same steps for component 2. After that, we will test our application to confirm that everything is functioning properly. So let us list the contents. First, I need to navigate into the main folder. From there, we will access the component 2 directory where the application files are located, and we will run the same set of commands as before to continue the deployment process. I'm going to run the export command to make it easier to see the terminal prompt clearly. Now, let's repeat exactly the same steps as before. In other words, I need to create a virtualized environment for the project, and then I need to activate this virtualized environment before proceeding. Then next, install the packages, the libraries. So notice the number of repetitive tasks you do to make a deployment. In this case, it's just 2 components and a front end. Now imagine having to manage dozens of components and performing all of this manually in a real-world deployment scenario. So we have deployed component 1 and 2, and now we are going to deploy the front-end dashboard service. Let's clear the screen and move on to executing the commands. At this stage, we'll be repeating the same set of commands we used earlier. This repetition highlights the need for automation. You don't want to manually run these commands every single time. That's why it's important to start thinking about more efficient ways to streamline this process. Now let's access the front-end folder and activate the virtual environment so we can proceed. First, let's create and activate a virtual Python environment. After that, just like before, we'll install the necessary packages and dependencies of the front-end service. The focus here is for you to clearly understand both the manual setup process and how this work can eventually be automated to save time and reduce errors. And now let's go ahead and run this command for the front-end application component service. Let's test access to all components. To do that, I'll retrieve the public IP address of the EC2 instance. In my case, I have already the security group set for these ports, 5000, 5001, and 5002. Let's first test port 5001 from the browser to see if the microservice is working correctly. The user service microservice component is up and running, which is responsible for tracking and displaying how many users are currently active in the system. Service online on port 5001. Now, let's test component 2. Great, the product service is running. At this stage, you're performing a manual deployment to ensure everything functions as expected. You've gone through all this effort to bring both microservices online and verify their proper operation. And now let's move to the third component, which is precisely our front end that communicates with the other two applications running on port 5000. The front end is working properly, successfully displaying content and seamlessly interacting with both microservices components, user and product services, expected during runtime. It communicates directly with these two services. You can click on View Interface and it will immediately open the corresponding microservices web page in your browser. If you click here on API Users, it will bring it up in JSON format in case you want to consume the API of these microservices. And that concludes the traditional deployment process. We ran the test, everything worked as expected. That wraps up part 1 of the TCB Docker edition. So, what are we going to do now? We're going to stop the application running in each terminal by pressing Ctrl+C to terminate the process. Go ahead and stop all running terminals, as this will interrupt the execution of the components we previously deployed manually. If we now try to access any of the services, they obviously won't respond anymore because they've been shut down. It is already crashed. We have successfully stopped the application components. This concludes part 1 of our walkthrough. I hope you will stick with us as we move into part 2, where we will demonstrate how to deploy the application using Docker. Remember that to do this, we will need the Docker file, which will allow us to build, create an image, and then execute that image using Docker. Thanks for watching and see you soon.
All right, thank you so much for watching this video. And then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content. And then also, please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering move to cloud, DevOps, and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.